Welcome to another edition of Math Teacher to Go. Today we're looking at the fifth and final part of our segment on the chain rule. In this part, chain rule part 5, we look at what we do when they give us a table of numbers for function values and derivatives. How does the chain rule apply to that? Okay. So how do we use the chain rule when we get a list of values? Your list may look like this, or it might look like a list of just listed across horizontally, but I gave you a table here. And the way you read this table is here's what x is. Here's what f of x is. When x is 1, f of x is 3. When x is 2, f of x is 2. When x is 3, f of x is 8. When x is 1, the derivative at 1 is 3, etc. Hopefully you can all read that table. Here's a classic problem that involves the chain rule. Now we've seen these tables with product rule and quotient rule. It's very similar here. If h of x is the composite function, that's what we call when we have a function inside of another function. H of x is the function f of g of x. Find h prime of 1. Well, the first thing you have to do is identify the outer function. The outer function is the last thing you do. So if you had x, you would put it into g and then put that answer into f. So f is the outer function and g is the inner function. You take the derivative of your composite function by taking the derivative of the outer function, f prime of, and leave the inside the same. We've seen this in the last few shows where if you have a function inside another one, the first thing you do is take the derivative of the outer function but leave the stuff you put into that derivative the same as what was in the original function. We had f of g of x. Our first step is to take the first derivative of f at g of x. Leave the g of x there, and you're going to multiply that by the derivative of what's inside. That's the essence of the chain rule. The derivative of g of x is g prime of x. Now, they had said find h prime of 1. So the stuff with the letters is kind of in there extra, but you may need that sometime. At 1, it's a little bit easier, though not really. You get f prime, the derivative of g of, it's not of x, you're being asked about it at 1. You want the derivative of g of 1, f prime of g of 1 times g prime of 1. Now you have to remember your composite function algebra here. You look up g of 1 in the table. There's g, there's x is 1. G of 1 is 2. So I replace the g of 1 with a 2. I look up g prime of 1. G prime of 1 is 7. I replace g prime of 1 with 7. And I still have to find, I have f prime of 2 times 7. So now I need to look up the derivative of f when x is 2. F prime of 2. There's the column for f prime. 2 is the second row. F prime of 2 appears to be 9. So I get 9 times 7 is 63. That's how I find h prime of x when h is f of g of x. Now what if they're reversed? What if g is on the outside? We've identified a new function, capital h of x, and that's g of f of x. In order to find h prime of 1, I have to switch what I'm doing. The question switches the inner and outer functions. And as you look down the screen here, I apologize for being so far down, that means g prime is the first thing you do and you leave the f of x alone. That was the original inner function. You have the outer function's derivative evaluated at the original inner function times the derivative of the inner function, which is now f. So you get g prime of f of x times f prime of x. I'm told x is 1. So I have g prime of f of 1 times f prime of 1. I look up f of 1 in the table and I get 3. So the f of 1 gets replaced with this 3. So I have g prime of 3 now. I look up f prime of 1. There's the column for f prime. At x is 1, it's 3. F prime of 1 gets replaced with a 3. But I'm not done because I still have this g prime of 3. I look at the column for g prime, go down to where x is 3, and I get 10. That gets replaced with a 10, so we get 10 times 3 is 30. You get two different answers. I got 63 in the first case when f was on the outside. I get 30 when G was on the outside. You have some homework problems like this, specifically number problem 39. Give those a try now. And thank you for joining me for this episode of Math Teacher to Go.